Welcome to Intelligence Gateway. Week 8, Data Mining. Introduction to Data Mining. Data mining is the process of discovering useful and valuable patterns or insights from large amounts of data. It involves identifying and extracting previously unknown and potentially useful information from data sets using various statistical and machine learning techniques. The goal of data mining is to uncover hidden patterns and relationships that can be used to make informed decisions and predictions. Data mining is used in a wide range of applications, including marketing, finance, healthcare, and customer relationship management. It is often used in conjunction with other data analysis techniques such as machine learning and statistical analysis to help organizations gain a competitive advantage and make better decisions based on their data. Data mining techniques: association rule mining, text mining, web mining, etc. Here are some common data mining techniques. 1. Association rule mining. This technique helps to identify patterns and relationships between different variables in a large dataset. 2. Text mining. It involves the extraction of useful information from unstructured textual data. 3. Web mining. This technique is used to discover patterns from web data such as web pages, links, and weblogs. 4. Clustering. It is a technique that groups similar objects or data points into clusters based on their similarities. 5. Classification. It is a supervised learning technique that predicts the class label of new data based on the labeled data. 6. Regression. It is a supervised learning technique that predicts the value of a continuous variable based on the input features. 7. Anomaly detection. It helps to identify the outliers or unusual data points in a dataset. 8. Time series analysis. This technique helps to model and forecast the future values of a time series data. 9. Dimensionality reduction. It is a technique that reduces the number of input features in a dataset while preserving the most important information. 10. Ensemble learning. It is a technique that combines multiple models to improve the overall performance and accuracy. Data mining tools and frameworks. There are many data mining tools and frameworks available, both open source and commercial, that help analysts and data scientists to perform data mining tasks efficiently. Some popular data mining tools and frameworks are: 1. KNIME. KNIME is an open-source data analytics platform that allows users to manipulate, analyze, and model data through visual programming. 2. RapidMiner. RapidMiner is an open-source data science platform that provides an integrated environment for data preparation, machine learning, deep learning, and predictive modeling. 3. Weka. Weka is a collection of machine learning algorithms for data mining tasks. It is open-source software written in Java and provides a graphical user interface for easy access to its features. 4. Orange. Orange is an open-source data visualization and data analysis tool that provides a drag-and-drop interface for building data mining workflows. 5. Apache Mahout. Apache Mahout is an open-source framework for building scalable machine learning applications. It provides a set of algorithms for clustering, classification, and collaborative filtering. 6. SAS Enterprise Miner. SAS Enterprise Miner is a commercial data mining tool that provides a comprehensive set of algorithms for data mining, machine learning, and predictive modeling. 7. IBM SPSS Modeler. IBM SPSS Modeler is a commercial data mining tool that provides a wide range of algorithms for data mining, machine learning, and predictive modeling. 8. Microsoft SQL Server Analysis Services. Microsoft SQL Server Analysis Services is a commercial tool for business intelligence and data mining. It provides a set of algorithms for data mining tasks such as classification, clustering, and association rule mining. These are just a few examples of the many data mining tools and frameworks available. The choice of tool or framework depends on the specific needs of the user and the task at hand. Week 9, Big Data Analytics. Introduction to Big Data Analytics. Big data analytics is the process of extracting insights and value from large and complex data sets that cannot be processed using traditional data processing technologies. It involves the use of advanced analytics techniques such as machine learning, predictive modeling, data mining, and natural language processing to analyze large volumes of data, identify patterns, and extract valuable insights. The big data analytics process typically involves the following steps. 1. Data acquisition, collecting data from various sources such as databases, social media, sensor networks, and other sources. 2. Data storage, storing the data in a distributed storage system such as Hadoop Distributed File System, HDFS, Apache Cassandra, or Amazon S3. 3. Data processing, processing the data using distributed computing technologies such as Apache Hadoop, Apache Spark, or Apache Flink. 4. Data analysis, analyzing the data using various analytics techniques such as machine learning, data mining, and statistical analysis. 5. Data visualization, visualizing the insights obtained from the analysis in a meaningful and easily understandable way using tools such as Tableau, Power BI, or Matplotlib. Big data analytics has numerous applications in various industries, such as finance, healthcare, retail, and telecommunications, among others. It helps organizations to make data-driven decisions, gain a competitive edge, and improve their overall performance. Big data analytics tools and frameworks, Hadoop, Spark, etc. Big data analytics involves processing and analyzing large and complex data sets to extract useful insights and make informed decisions. To handle such large data sets, several big data analytics tools and frameworks have been developed. Some of the popular ones are: 1. Hadoop. Apache Hadoop is an open-source software framework for storing and processing large data sets. It uses a distributed file system and a MapReduce programming model to process large volumes of data across multiple nodes in a cluster. 2. Spark. Apache Spark is an open-source data processing engine for large-scale data processing. It is designed to be faster and more flexible than Hadoop's MapReduce programming model and provides support for real-time stream processing, machine learning, and graph processing. 3. Flink. Apache Flink is another open-source data processing engine that provides support for stream and batch processing. It is designed to be highly scalable and fault-tolerant, and provides support for real-time stream processing, machine learning, and graph processing. 4. Cassandra. Apache Cassandra is an open-source distributed database management system designed for handling large and complex data sets. It provides support for high availability, fault tolerance, and scalability, and is used in several large-scale applications. 5. Elasticsearch. Elasticsearch is an open-source search and analytics engine designed for handling large volumes of data. It provides support for full-text search, real-time analytics, and machine learning, and is widely used in several applications such as e-commerce, social media, and log analysis. Use cases for big data analytics. Big data analytics has numerous use cases across various industries. Some of the common ones are: 1. Fraud detection. Big data analytics can be used to detect fraudulent activities in the financial industry. By analyzing large amounts of data, it is possible to identify patterns and anomalies that indicate fraudulent behavior. 2. Customer segmentation. Big data analytics can help companies segment their customer base based on various parameters such as demographics, purchase history, browsing behavior, etc. This can help companies personalize their marketing campaigns and improve customer engagement. 3. Predictive maintenance. Big data analytics can be used to monitor equipment and predict when maintenance is required. By analyzing data from sensors and other sources, it is possible to identify patterns that indicate potential problems before they occur. 4. Supply chain optimization. Big data analytics can help companies optimize their supply chain by identifying bottlenecks, optimizing inventory levels, and improving logistics. 5. Healthcare. Big data analytics can be used to analyze patient data and identify patterns that can lead to better diagnosis and treatment. It can also be used to monitor the effectiveness of treatments and identify potential side effects. 6. Smart cities. Big data analytics can be used to optimize city services such as traffic management, waste management, and energy consumption. By analyzing data from various sources such as sensors, cameras, and social media, it is possible to identify patterns and optimize city services. 7. Social media analysis. Big data analytics can be used to analyze social media data and identify trends, sentiment, and other patterns. This can help companies improve their marketing campaigns and understand their customers better. These are just a few examples of the use cases for big data analytics. As more and more data is generated, the potential for big data analytics is only going to increase.